Welcome to my channel in the Physics Made Easy. Do you know why the door or knob in the handle is attached at the outer edge, far away from the hinge? What may be the reason? When you open the door, what do? You apply the force. What is the effect of force? That is, we are going to discuss the effect of force in rotational motion. Why rotational motion? Whenever you apply the force, what happens? The door turns around the hinges. So the turning effect of force, rotational effect of the object which is pivoted at certain point and the force is applied, that is called moment of force or torque. All these names are same. When the linear motion in a straight line, object is moving with the uniform velocity. When the force is applied, what happens? Its velocity increases or decreases. Similarly, when the body is rotating about the fixed axis, then what is that term which changes its rate of rotation? Its angular velocity increases or decreases. By what? That term is called moment of force or torque. So today we will discuss about torque. What is torque? What is its formula? What is its nature, whether it is vector or scalar, its unit, and why to learn it? Because in rotational motion, to change the speed of angular speed of the rotating body, torque is required. If no torque is there, the object will continue to rotate with the constant angular speed. Let us discuss. As we have read in linear and angular or rotational motion, displacement, then angular displacement, velocity, then angular velocity, acceleration, then angular acceleration. Also we have read that S equal to R theta, the formula V equal to R omega and A equal to R alpha. These are the magnitudes. How are they? Linear and angular quantities, they are related. But in the vector form, we have read this theta, omega and alpha. These all are vector, and angular displacement, angular velocity and angular acceleration, what I told, that all the terms in which angular word is attached, their direction is along the axis of rotation. And how it is determined? By right hand thumb rule or right hand screw rule. How this vector form is given? This is V equal to omega cross R, not R cross omega, because vector product is not commutative. Omega cross R will have a direction perpendicular to the plane of omega and R along the axis in one side, and R cross omega along the same axis but in opposite direction. Similarly, here this acceleration is given by alpha cross R. Now, in the linear motion, if you want to change the speed of a body, what is applied? Force. What is parallel to it in the angular or rotational motion? That is called torque. And this torque is the product of the force and distance. Which distance? If you see that an object is pivoted like this, I am showing which distance. This is the axis passing through the pivot. Okay. At this point P, a force is applied. So if this is the force applied at the point P, what happens? If you join the point P with the origin like this. This is the distance r. Then this is called position vector. If you extend the position vector in this direction, and if you extend the force vector in forward or backward, then these are called the line of action. This is line of action of force, or this is the position vector r, whose direction is given like this. Then torque is the product of this rotational tendency of force, or torque is product of the perpendicular distance from the axis on the line of action. Look, if you draw the line of action, then this point is suppose n, then ON is the perpendicular distance on the line of action from the axis. So you can write here, this torque is the product of ON and F. Okay. What is this ON? This R is the position vector, R is shown by vector. If this is the angle theta, then this will be the angle theta. This ON can be written, this ON will be R sin theta. From which triangle? Triangle ONP. If you see this OP is R, then ON will be R sin theta and NP will be R cos theta. So you can write here this R sin theta into F. What is torque? How will you define torque? Torque is the rotational tendency of force about axis of rotation. It is measured by the product of perpendicular distance of the force applied on the body from the axis of rotation. This torque, why this is called turning effect of force? Have you seen that in a door, if suppose a door has hinges here and here, and this is the door, okay, the handle or knob is provided at the outer edge. This distance from the handle is perpendicular distance. Suppose this distance is R. This is called moment arm or lever arm. And if you apply the force at this knob, then door is open or closed as per the situation. What happens? The door turns around the hinges. This turning effect of force, whenever you apply the force, I am showing like this, this turning effect of force is called torque. Now the amount of turning, if you see the amount of turning, then this amount of turning depends on number one, magnitude of force. How much force? Larger will be the force applied, more will be the turning. Second, the distance of the force applied, that is the position of the force applied from the axis of rotation, that is R. Also, at what angle the force is applied, at what angle. What is this? You know, when you apply the force perpendicular to the knob, the turning will be easier. So amount of turning depends on these three factors. How much is the force applied? More is the force applied, more is the turning. Distance of application of force from the axis is more, then more will be the turning. And for the angle at which the force is applied on the object, then more will. It depends on the sine theta of that, because theta is more. If more is the value of theta, 90 angle sine 90 degree is 1, so sine theta. Here you have seen that torque I described earlier, F, R and sine theta. We have seen the formula. You can also explain, suppose you have seen the nut and bolt. If this is the nut and suppose this is the handle of the bolt, look, you want to open the nut, okay? What happens? If you apply the force here or if you apply the force here in the first case or second case, can you imagine in which case easier will be the turning, or you can easily open the nut? You can see that at the point F1, if you apply the force, then more force will be required to open as compared to at the point 2. What does it mean? That if lesser is R, lesser will be turning, more will be the R for the same force. If more is R, then more will be the turning. So similarly, if you want to understand how this theta, so look here, if you apply the force like this, okay, this is the application of force at this point. Look, from here to here, this will be the R, okay. If you see the position vector R in this direction, this is the direction of R. Look, this force will have two components, one perpendicular, suppose R and F are directed at angle theta, and one parallel to R. This will be as usual of F cos theta and this will be F sin theta. Which component of force will be responsible for turning? As we have seen, if you apply the force perpendicular to it to rotate it, okay. Here you have seen that F cos theta is parallel to R, so it has no role in turning. Only the force which is F sin theta at the 90 degree, for F sin theta we have seen this component, it is from R at 90 degrees, so sin 90 will be maximum 1, and we have seen R into F sin theta, whatever is the product torque, formula for torque. Now this torque product of this moment arm and the force applied is a vector quantity. How it can be written? This torque is given by R cross F. You know, vector quantity is, vector product is a vector perpendicular to the plane containing R and F here. Here, which two pairs are? Write the two pairs whose dot product is 0. Torque dot R will be 0, torque dot F will be 0. Why? Because this torque is perpendicular to both R and F. So how this A cross B, AB sin theta n cap? What is n cap? Unit vector perpendicular to the plane of A and B. Here you have seen this R cross F can be written R F sin theta, you can write in this way, or you can write R sin theta into F. Is it visible? Here, look, R sin theta into F. So either you can write R into F perpendicular, or you can write R perpendicular into F. How? I can show you that. If you see the object, suppose at the point P here, I have shown here, look, this ON. What is ON? R sin theta. So what will be the torque? This ON into force applied. And how will you determine the direction of torque? Look here, this ON is this one. This is R sin theta. So R sin theta into F, and this is the direction of R. Here I have shown here that this R into F sin theta. So either you take the product components of force, or the components of r. Okay, is it clear? There is no role of F cos theta or any component of force which is parallel to r or any force which is passing through the origin. It will not rotate the object. It will not produce any turning effect. Look how the direction of torque is determined. A little bit confusion arises in the mind that how, in what direction we should take theta. Look here, this is the position vector r, this is the direction, this arrow represents the position vector's direction, and this is the force. Note down that right hand thumb, the curling of the fingers will be from r towards f, smaller angle side, not from this side. If you see this is r, this is f, then you can say like this will be the, no, this angle will be more, this will be lesser. So from r towards f, if the curling of the right hand finger, then thumb gives the direction of torque. Look here that what will be the direction of torque here? This is r, this is f sine theta. You look here, this is f, r cross f, this will be the torque. If the force is applied, suppose this is the pivoted point, if the force is applied like this and this is the r. Okay, now how will you select? Don't do like this. What is the direction of force? Look here, this is the direction of force, then r towards f, then this will be. So remember, in this figure the thumb is inward, this is r and this is f, then thumb is inward and perpendicular to the plane of r and f. In this figure, the r cross f, this is, the thumb is outward. So direction of torque, if you find, then there are two directions. One is anti-clockwise, that is positive, and anti-clockwise, look here, this one is, you can say, outward. Remember, in any of the ways it is given in the question. And other is clockwise, it is also said to be negative, and inwards. I have explained here in this figure. So in this way, what about torque? What is the unit? Look here, Newton meter. So direction, unit, and how the torque is calculated, how the theta is considered, I told you. Suppose there is a figure in which various forces are given. This is the axis and object is here pivoted. Okay, at the point P from the origin O, the distance is position vector, suppose this is r. Okay, now at this point P, one force is applied in this direction, other force is applied in this direction, next force is applied in this direction, F3, this force is applied in this direction. Okay, this is F1, F2, this is F3, this is F4. Okay, find the torque. Then how will you calculate? Look here, this OP is the position vector and in the same direction the force is F1. What I told here, if the R and force applied are parallel, then there will be no torque. Why? Because this R cross F will be 0. So F1 will not produce any torque. What about F2? You know, this is the direction of R and this is F2. So if you see that this R cross F, look here, what I told, torque is R cross F and vector form. Look here, right hand, curl the right hand, this is R towards F. Look, will be or not? So due to F2, what will be the direction? Look here, look my thumb, from R towards F. Look, so inward. Look here, inward. So this will be clockwise. What about F3? Here, this is the direction of R and F3. So in this way. So you can select this is F3 will be anti-clockwise. Okay. Look, outward or anti-clockwise or positive. What about F4? In the same way, R cross F, then R cross F will be outward, that is anti-clockwise. Due to which force torque will be maximum? These are the directions. As you know, theta is 90 for the force F4 because this is the direction of R and F4. Theta 90, sine 90 is 1. So due to F4, the torque is maximum. What are the rectangular components of torque? If you know that the distance position vector, not the distance, the position vector and the forces are written in 3D. How in terms of rectangular components, this R can be written as xi cap plus yj cap plus zk cap, and F can be written as fxi cap plus fyj cap plus fzk cap. Then what will be the torque? How will you find the relation for torque? Simple, cross product, and R cross F. Then how will you write this I, J, K? You know the cross product. Then for R you will write x, y, z. For F you will write fx, fy and fz. You will find the product, cross product, and you can find that you will get this I cap, this and this line will be missing, then y into fz minus z into fy plus j cap, then this and this line will be missing, then this time you will find z into fx minus x into fz. You learned the method of this vector product, and plus k cap, again this k, ijk you have written, then this column and this row will be missing, then you will find again this x into fy minus y into fx. Learn this, the term written in bracket, this is I, and you will write this is tau x, this is tau y, and this is tau z. In some of the numericals, it is important to learn, find the x component of torque, then this is connected with, written with I, this is torque y and this is torque z. One question given in AI PMT 06 paper, it was asked that the force acting is along negative z axis minus fk cap. Find the torque across the point 1 minus 1. How will you solve? You draw the axis like this, okay, and if you see, this is, suppose this is x, this is y, this is z, then force is along this axis, okay, minus fk, and what will be 1 minus 1? Look here, x, y, so x is positive, y is minus 1, so the point will be somewhat here. You look here, this will be the point P having 1 minus 1. What will be the position vector for P? You know what will be R here. You should learn to write this position vector for P will be this I minus j. K will be 0, it is not given. Put here I, j, k, and here this x, y, z and fx, fy, z. You will find what will be the answer? You know what will be the torque? R cross F. By this formula, you will find this will F I plus J. How? You can check with this relation. So in this way, how the torque is applied, how the torque is calculated, and for the system of particles, if you have seen the force is applied at one particle of the rigid body, then rigid body is made up of n particles, then summation, algebraic sum, not algebraic sum, all the particles sum, torque is a vector, so vector sum of all the torques acting on individual particles. How can you write here? This will be the sigma from I equal to 1 to n. This torque will be equal to this sigma R cross F. Okay. So this we will see how the torque is calculated for the system of particles. So in this way, I told you how the torque is obtained, how the F sin theta or into R or R sin theta into F is equivalent. There is no role of any force which is passing through the origin or it is parallel to the R position vector. Now can you give any example in which torque is acting but there is no rotation? It seems different. Torque, its name is rotational effect, but torque is present, no rotation. Look, if there is a disc, okay, I have taken the example in which the disc is pivoted at the point I'm showing like this. This is the disc and it is pivoted here and the axis is passing through it. Now at this point, suppose this is the R. A force, disc is rotating about this Z, this axis. Okay, this is the axis of rotation like this. If the force is applied parallel to the axis, okay, like this, what will happen? This is the direction of R and this is F. I am going to show you. This is the R and this is F. So R and F, this R and F will produce torque in the direction of thumb. So if you see that this is the disc, okay, this is the disc, force is applied in this way and this is the direction of R. Then R cross F, if I curl the finger, R cross F, then what will be the thumb? R cross F, like this. So torque will be in this direction. In the plane of disc, torque will be there. Torque is non-zero, but the disc will not rotate. Why? Look here, the torque will act in this direction. How can in 3D I can show this? Why? Because this F is parallel to the axis. So this rate of rotation will not change. It will continue to be moving, or if it is at rest, it is not moving, even then this force will not rotate the disc. Disc is at rest, it will not rotate. So what happens that if the force is applied like this, okay, now what will happen? Look, if the force is applied like this, then one component of force will be this one and other component of the force will be this one. Now what will happen? That if the disc is there, if the force is applied in this way, then one component of the force will be this one and the other component of the force will be this one. Then you can find that which component will rotate the disc. If I show the force like this, then this will be the component F1 I can show you, and this will be the component F2. This is the F2 I can show here, and this will be the F1 like this. The F1 will produce torque and F2 will not. Why? Because F2 is this, parallel to the axis. So in this way the questions are asked based on the torque. Learn the logic, learn the fundamental things about the direction and magnitudes of the R and F. Now I hope you must have enjoyed it. Thank you.